Good morning, Chriselle, Billy, and Victor. Sorry. So now we're at week number 13 for math of the semester, and we are starting a brand new chapter now for Math 151. We'll be talking about chapter 4, which is all about Laplace transforms and how this transform is used in solving ordinary differential equations. Now, uh, I think this is the last portion of the course per the redesigned course outline. Pero way back in the day when I took 151, I medyo may iba pang topics after the Laplace transform. Basically, how to solve systems of linear differential equations. Pero unfortunately, dahil cut short yung semester, so kaya medyo mas pinaiksi pala nila yung coverage. So which brings me to the final exam, which the pre-final exam rather. So yung pre-final exam is still scheduled to be face-to-face. So it's still we're still targeting December 12. That's Monday after next. So Monday, and then it's 10 to 12 noon. Okay. So if you have valid reasons why you are not available from 10 to 12 noon on Monday, December 12th, so kindly let me know ahead of time so that mahanapan ko kayo ng alternative time, but preferably within December 12th. So this is still scheduled to be face-to-face, so I hope you are starting to arrange your transportation or your accommodation in Los Baños if you're not already staying in Los Baños. Kasi yun nga, face-to-face to, and then there would be no replacement for missed pre-final exam, unless of course there's a valid reason for you missing it. Baka final exam yung ipapalit ko dun sa pre-final exam. And then I'm still talking with the other lecturers about the coverage. So definitely ang start nito ay yung hindi natin nasama sa midterms hanggang dun sa matatapos natin. I guess we only have 3 meetings including today. So hanggang Friday next week na lang yung discussion natin for the pre-final exam. I am proposing dun sa mga lecturers na meron na lang face-to-face part yung exam, and then there's a take-home part. And then I'm proposing na medyo straightforward sana yung ibigay namin na face-to-face problems kasi the problems in our midterm exam admittedly will take some time for you to answer. Hindi nga lang to answer pero para isipin kung paano siya i-solve, iintindihin niyo pa yung problem, yung pagkakasulat ng problem. Well, that's specifically designed to require you thinking kasi nga take home yung exam. Ang iniisip ko for face-to-face exam, sana minimum competencies, makita lang namin na marunong kayong mag-solve. So okay na para sa akin yun. But I'll need to talk with the other lecturers. And anyway, my bargain is to have a second part of the exam, which is take home, para doon namin kayo matest some more complicated problems or problems in the higher order thinking range. So I hope that is okay. And then the advantage also of a take-home part is pwede ko pa kayong i-test dun sa mga madidiscuss natin after December 12th. Because I think we still have 2 or 3 meetings after December 12th. So matatapos pa na rin natin yung coverage ng redesigned course. Okay? So I hope that's okay. Any questions about this? Okay, so kung wala, so let's get going kasi medyo parang 2 meetings behind ako the other lectures. So let's see. We'll start chapter 4 as I've mentioned, and chapter 4 is all about Laplace transforms. Well, ideally, the basically Laplace transforms really transforms, as the title suggests, transforms the given function into another function in another domain. So ang gagawin natin, meron kang given function, tapos papalitan natin to. Papalitan natin ng itsura. It will undergo a transformation, a makeover if you will, to a brand new function in a different domain. Ang kagandahan sa Laplace transforms is the Laplace transforms handles differentiation easier. So ganito yung mangyayari. So halimbawa, meron kang function, meron kang ODE. Tapos sa ODE involves si function, say, anong ginamit ng variable dito? I forgot which variable we'll be using later, but let's see, you have a function capital F of the time variable t halimbawa. So ito yung involved dun sa ODE. Well, currently, our setup is to use some techniques to solve this ODE and get the function, say, x, right? Get the solution, say, x of t, right? So meron kang ODE na involves si function capital T. It could be the right-hand side of your equation or whatever. So you still have a function f. Gagamit ka ng mga techniques na discuss natin all throughout chapters 2 and chapter 3 para makuha yung solution x of little t. Now, what the Laplace transform does is that it will give us a different take on the function f. So papalitan natin siya ng itsura, right? From a function f of the variable t, we will have a function little f of the variable s. So binabago natin yung domain kung saan na-define yung isang function. Now here, pwede mo itong tingnan as the time domain. Usually, ang mga problems kasi natin naka-time domain or whatever your t represents. So it could be a spatial domain or whatnot. So you have a certain domain in the original problem. When we Laplace transform it, we usually transform it into a function in the frequency domain. Bakit natin to ginagawa? Kasi yung ODE sa time domain, pag ni-Laplace transform mo, ay magiging isa na lamang algebraic equation. Meaning, wala nang derivatives na involved dun sa makukuha mong equation in the frequency domain. So the idea is, again, you have an ordinary differential equation in the time domain. So that means you have an equation that involves the variable with respect to the derivative with respect to time. Pero kapag kinuha mo yung Laplace transform ng dalawang sides ng ODE mo, makakuha ka ng isang equation sa frequency domain involving the transformation function little f of the variable s, pero wala ng derivatives na involved. So it will just be an algebraic equation. So instead of going through the techniques na discuss natin sa chapter 2 and chapter 3, kakalimutan na natin yon. Kasi ngayon purely algebra na yung pagko-compute natin ng solution para dun sa algebraic equation in the frequency domain. Now, what we get here would be a solution using algebra techniques in the frequency domain. Let's call it x tilde s. All right? So ito yung makukuha nating solution. Nasa frequency domain ka pa rin, pero ang kagandahan dito, hindi mo dadaanan yung mga calculus techniques na diniscuss natin in the previous chapter. So simple algebraic manipulation, how you usually solve algebra equations. Yun yung gagamitin natin para makuha yung solution x tilde of s. Right? Tapos, to address our original problem, kukunin ko yung inverse Laplace transform so that I can convert the function x tilde in the frequency domain into a function in the time domain. So yun yung nangyayari. Parang nagbabago tayo ng dimension, nagta-time travel tayo or nagdi-dimension travel tayo. Sinusolve natin yung isang alternative equation sa kabilang dimension, tapos magko-conversion lang tayo pabalik dun sa original dimension kung saan na-pose yung original problem. So basically, that's the general idea behind chapter 4. But essentially, the first question is, what is the Laplace transform? And what are the functions that can be easily transformed following this methodology? Kasi usually ito yung major ito yung major motivation. Hindi mo kailangan yung mga techniques na napaka-komplikado from chapters 2 and 3. If you know the Laplace transform of your function f and consequently kung swerte ka ng inverse Laplace transform ng solution mo ay madaling i-compute, then it's better to solve the algebra problem plus the conversion the steps kaysa isolve yung ODE head-on in the time domain. Okay? So at the end of the chapter, so meron tong pitong, makikita nyo may pitong sections, Pero 3 araw na lang yung meron tayo pa before the exam, or 3 lectures na lang before the exam. Let's try to finish as much as we can. Pero at the end of the chapter, you should be able to, number 1, find the Laplace transforms of elementary functions. Emphasis on elementary functions kasi hindi lahat ng functions ay madaling hanapan ng Laplace transform. And then second, we want to capitalize on the use of the Laplace transform in solving differential equations. And actually, ito yung nilulook forward ko sana, how to use Laplace transforms in solving systems of differential equations. Kasi nagiging ano lang siya, matrix system kapag system of ODEs na napaka-komplikadong isolve, pero pag ni-Laplace transform mo siya, nagiging mas madali siya. Okay? All right, so let's start with how the Laplace transform is defined. So kung given ka ng function capital F na ang variable niya ay t, or in the time domain, kapag ang variable ka ay t, tatawagin ko siyang time domain. Tapos kapag ang variable s ko na, pwede ko siyang tawagin transform domain o frequency domain. So you start with the function f of the independent variable t. The Laplace transform of that function capital F is denoted by this. L, curly braces, tapos nasa loob si f of t. Now, paano mo kukomputin yung Laplace transform na to? So this is read as the Laplace transform of the function f. Now, to compute it, you need to compute the integral of e to the negative st, f of t dt from 0 to infinity. And if that improper integral exists, then that will be a function of s. Bakit siya magiging function of s na lamang? Kasi rito merong seemingly dalawang variables, si s at saka si t, but we were told to integrate only with respect to t. So you find the antiderivative of this product, and whatever you get, you evaluate it from 0 to infinity. So lahat ng t's mapapalitan ng 0 to infinity, so essentially the variable s will remain. So if this improper integral exists, then that function little f, kung saan equal yung improper integral na yan, will be a function of the frequency domain, S, and that is what we will call the Laplace transform of capital F. Okay? So pakitandaan, ano to? So integral lang siya nung given function against e to the negative st, then evaluate this from 0 to infinity. Okay? So, ito yung kabayaran ng pagsa-solve ng isang ODE by converting it to an algebraic equation. The diagram I showed you earlier is very enticing kasi instead na calculus techniques and chapters 2 and 3 yung gagamitin mo pag-solve ng ODE, may paraan naman pala siya para isolve siya using algebra lamang. Pero ang cost noon ay kailangan mong computein yung Laplace transform. And the Laplace transform is this improper integral. Not all functions have a Laplace transform. Kasi nga kailangan mag-exist muna itong integral na to. But at least for elementary functions or for easy functions, meron silang magagandang Laplace transforms. Okay? Now let's try to look at some examples. Okay? But before that, theorem pala muna. So theorem 1 here, theorem 4.1.1, basically tells us that the Laplace transform is a linear operator. So kapag kung nag-exist yung Laplace transform ni f at saka yung Laplace transform ni g, then ang Laplace transform ng linear combination nilang dalawa, right? So you have a constant a times a function f, you add it to a constant times a function g, you take their sum and you want to get the Laplace transform of the sum. Yan lamang ay scalar times the Laplace transform ni f plus scalar times the Laplace transform ni g. So this tells us two things in one line. Dalawa yung sinasabi niya. Ang Laplace transform ng sum ay sum ng Laplace transforms. So you can do term by term Laplace transformation. And secondly, kapag kinukuha mo yung Laplace transform ng scalar product ng isang function, yung scalar multiplier ay pwedeng lumabas ng Laplace transform. So when you say it's a constant, dapat hindi siya nag-involve ng variable t. Well, the proof just relies on the linearity of the integral operator, because if you remember, the Laplace transform is basically an integral against e to the negative st. So we can expect that all properties of the integral will still be or will be inherited by the Laplace transform. And true enough, kung ipoprove nyo yung theorem 4.1.1, ang assumption natin nag-exist yung Laplace transform ni capital F sa ni capital G. So that means the improper integrals 0 to infinity of e to the negative st f of t dt, and the integral from 0 to infinity e to the negative st of, there's a typo, this should be g of t, ay pareho nag-exist. Galing dun sa assumption natin na nag-exist yung dalawa. Okay? And then now, I want to find the Laplace transform netong sum. Gusto kong ipakita na yung Laplace transform na to ay equal dito. Or actually, you can do it also the other way around. You can start with this guy and eventually show that this guy simplifies to this guy. So you can pick your poison, pero sige, let me add a page para pwede kong ipakita yung proof. I'll start with the left-hand side of the equation in the theorem and show the right-hand side. So pakita natin yan. Hindi ko napigilan. Sabi ko ay hindi ako mag-i-insert ng mga pages. Susundan ko lang yung nasa slides, but I can't help do it. I can't help doing it. But so, yes, relax lang tayo. Huwag tayo magpa-apekto sa deadline ng pre-fi exam, no? So what I want to get is a Laplace transform of constant times f of t plus b g of t. Okay? Kunin ko yung Laplace transform na yan. Gusto ko ipakita ito ay equal sa a Laplace transform ng f plus b Laplace transform ng g, which is the claim in the theorem. Okay. Now I'll use the definition here. I'm taking the Laplace transform of this guy. It's essentially this will be the improper integral from 0 to infinity of the function inside the curly braces times e to the negative st. So e to the negative st times the function inside the curly braces, aft plus bgt with respect to t. And then I can distribute e to the negative st inside the sum. So this will be integral from 0 to infinity ng e to the negative st times a f of t plus e to the negative st times b g of t dt. All right. And then I can split this into two sums, right? Kasi nga, yung bawat improper integral, alam ko ay nag-exist. Or basically, what should I do first? Yeah, I can split the definite integral first. So this would be from 0 to infinity of e to the negative st times a f of t plus e to the plus integral from 0 to infinity of e to the negative st times bg of t dt. Okay. And then I can use the linearity of the integral operator. I can take out the constant a outside of the integral. A integral from 0 to infinity of e to the negative st f of t. Oops, I forgot the dt here. Okay. dt plus, then I'll take out b as well. 0 to infinity e to the negative st g of t dt. Okay. And then we knew that this exists. And they are exactly the Laplace transform of the functions big F and big G, respectively. So therefore, this is A Laplace transform of f of t plus B Laplace transform of g of t. End of proof, right? This was a nice exercise kasi paulit-ulit kung kailangang isulat yung definition ng Laplace transform na may e to the negative st times your function big F and so on. So para matandaan natin, maukit sa ating mga memorya kung ano yung Laplace transform. Okay? So that really shows that the Laplace transform is a linear operator. So yung mga linearity property ay pwede nating i-apply whenever dealing with the Laplace transform. Right? All good? So I know you can write the proof on your own, pero gusto ko lang siyang isulat out there para ma-familiarize tayo dun sa definition ng Laplace transform. All right? Okay, now, tapos na in section 1. Yun lang yung definition ng Laplace transform. Section 2 gives us or computes the Laplace transform of elementary functions. So, hindi ko na itinago yung proof, alright? Kasi rin wala akong copy ng actual PowerPoint, yung PDF lang yung nakuha ko. Pero sabi ko nga, bibilisan ko, so hindi ko na to ila-live, ano? Pero susundan natin step by step yung mga integrals na nandito sa slides para makita natin yung idea behind the Laplace transform. So theorem 4.2.1 tells us na ang Laplace transform ng isang exponential function of the form e to the kt, where k is a constant, all right? Ito ay equals to 1 over s minus k with the restriction that that s is greater than k, right? So this will work perfectly fine if you have the function say e to the t. Okay. So papangunahan ko na yung example, pero para ma-illustrate yung utility ng theorem na to. So here, if you want to get the Laplace transform of e to the t, of course, without the knowledge of theorem 4.2.1, you need to go through the definition, integrate e to the t against e to the negative st, take the value of the improper integral from 0 to infinity, then you'll get your Laplace transform. Okay. But with the aid of theorem 4.2.1, we know that this, or we just need to notice that here, k is equal to 1, right? So therefore, the Laplace transform is 1 over s minus 1, where s is a number greater than 1. So your frequency domain here is restricted to those positive numbers greater than 1. Okay? So parang ang dali lang pala, no? So kung ganito lang pala kadali yung pagla-Laplace transform, so parang worth it yung conversion, ano? Mula dun sa ODE papunta sa algebraic equation, tapos yung conversion mamaya, yung inversion, ay makikita natin na ganun din kasimple para sa elementary functions. Right? But that's the gist of theorem 4.2.1. Well, the proof is simple. You just need to, or at least the idea is simple. You just need to apply the definition ng Laplace transform sa e to the kt. Evaluate natin yung improper integral. So by definition, the Laplace transform of any function is the improper integral from 0 to infinity of that function times e to the negative st. Laging may e to the negative st dun sa definition ng Laplace transform. And integrate with respect to t. Now, laws of exponents were applied here. Para isa na lamang na power ni e yung i-deal with natin. And then here you can factor out the t as what was done here. Tapos recall, we are evaluating an indefinite integral because the upper bound is infinite. So ibig sabihin, kailangan ko itong ilipat into a limit problem. So hopefully you still remember your improper integral. Saan nyo ito na-encounter? Math 37 na. So I hope tandaan nyo pa rin. So dahil ang cost ng pagiging improper ng integral ay unbounded above siya, so papalitan nyo lang by a dummy variable, yung upper bound, and take the limit of that dummy variable as it approaches positive infinity. Para rito, pwede kayong gumamit ng fundamental theorem of calculus. Kasi hindi nyo magagamit yung fundamental theorem of calculus kapag ka-infinite yung isang bound. Okay? So take the integral of e to the negative e to the k minus s times t. Ang integral niya lamang ay ito. But the limit, but you need to evaluate it from 0 to b, and eventually take the limit as b approaches infinity. Okay. Now, when we plug in b here and 0 here, we'll get this guy. So plug in nyo lang yan. Si b at saka si 0, take the difference, and then eventually we'll get this because you get a 0 here. So this term here goes to 1. So ito lamang, tas copied over yung minuend. Okay. Tapos let's see what will happen. There are 3 cases here. Una, kapag kasi k minus s ay greater than 0. Kapag kasi k minus s ay positive, so k minus s is positive. So that means this guy will be e raised to a positive multiple of b. But b is going to positive infinity, right? So essentially here you will have e, ang indeterminate, ang form nito ay e to the positive infinity. Lagyan natin ng quotation marks, ano? Baka magalit yung mga purist mathematicians diyan, ano. Pero yung idea niyan, kapag si k minus s ay positive number, so ibig sabihin ang forma ng e to the k minus s times b ay e to a large number, right? Kasi kinukuha natin yung limit as b approaches positive infinity. But what is e to the positive infinity in air quotes? Yung e to the positive infinity, if you raise e to a very large number, you get back a very large number. So this is positive infinity. Divided by a constant, it doesn't matter. It will still be positive infinity minus 1 over k minus s. All right? So ibig sabihin, positive infinity yung value ng improper integral kapag kasi k minus s ay positive. So that means the Laplace transform does not exist whenever k minus s is greater than 0, or alternatively, when k is greater than s. Pero sabi naman ng theorem, wala tayong pakialam sa case na k is greater than s because apparently it will not exist because the improper integral does not exist. Now, when k minus s is exactly 0, then we won't be able to write this quotients in the first place kung si k minus s ay 0 kasi si k minus s pala ay nasa denominator. But what is the case when k minus s is 0? Balikan natin yung definition ng Laplace transform. So ito yung magiging itsura ng application ng definition. And then here, remember, we're gonna write this as e to the k minus s times t. But here we are assuming in this case that k minus s is 0. So essentially the integrand in this improper integral is e to the 0, which is 1. So essentially when k minus s is equal to 0, the Laplace transform will be equal to the integral of dt from 0 to infinity, which is divergent. Okay? So hindi rin nag-exist yung Laplace transform kapag kasi k minus s ay equal kay 0. Now, the only interesting case here is when k is less than s. Kasi when k is less than s, that means k minus s is negative. So kung si k minus s ay negative, so this is a negative constant times something approaching positive infinity. So this guy will sort of approach e to the negative infinity, or is of the form e to the negative infinity. It's e to a large number, to a large negative number. So essentially, you can think of it as 1 over e to the infinity. E to the infinity goes to infinity, so this is 1 over infinity. 1 over infinity is equal to 0. So that means this is going to 0 in the limit, leaving us with only negative 1 over k minus s. And then just to make things looking better, itong negative na to, pwede kong isama sa negative sa baba, and I'll get s minus k. So therefore, if you put the restriction here that s must be greater than k, then we found the Laplace transform for e to the kt. It is simply 1 over s minus k. All right? Any questions with that derivation? Hold on, guys, while you're thinking. May tanong ba? Okay. So if there are none, it's okay if we proceed to examples. Ito. Actually, may sagot na siya. So kailangan takloban ko yung sagot. Huwag na nating takloban. Ano? Ang dali lang naman kasi ng formula. Laplace transform ng e to the kt I equals to 1 over s minus k. You can just remember here that s should be greater than k. So dapat positive yung denominator. Now in example number 1, k is equal to 2. So that means we'll have 1 over s minus 2. Easy peasy, right? S greater than 2. E to the 3t, no problemo, because here k is equal to 3. So all we need to do, replace k by 3 in our formula, we're gonna get 1 over s minus 3, where s is greater than 3. Kung ayaw nyo magsaulo ng formula, di-evaluate nyo yung improper integral from 0 to infinity ng e to the negative st times e to the 3t dt. And you'll get 1 over s minus 3 whenever s is greater than 3. Okay? Now, e to the negative 5, in this particular case, k is equal to negative 5. So now the denominator would be s minus minus 5. So, and the restriction here, s is greater than -5. Tapos dito sa example number 4, ginamit niya yung linearity ng Laplace transform. So here, you get the Laplace transform of 2e to the -60. Pwede kong ilabas yung constant ng Laplace transform. So it's going to be 2 times Laplace transform ng e to the -6t. Tapos ngayon, magkakaroon ka ng 2 times. Apply the formula for the Laplace transform of e to the -60. In this case, our k is equal to -6. So we'll have 1 over s minus minus 6. So that's going to be s plus 6. And our only restriction is that s is greater than -6. When simplified, that will give you 2 over 6 plus s, s plus 6. Okay? Everything's good? So, so uluhin nyo na to. Kailangan nyo yan sa exam. Hindi ko alam kung papayagan namin kayo magkaroon ng cheat sheet ng Laplace transforms, ano? Pero at least isa pa lang to, madali siyang tandaan. Good? Parang tahimik nyo. Okay, there we go. Next, ayan, pakomplikado na ng pakomplikado yung mga formula. Susunod, Laplace transform ng sine of kt. Well, the proof of this still requires integration. Kaya lang ang i-integrate nyo ay, ang kailangan nyo i-integrate ay 0 to infinity e to the -st times sine kt dt. Now, you can use integration by parts for this. Para makuha niyo yung integral. I think that's fine. That should be fine. Or an alternative would be to use Euler's formula involving complex numbers, which we used when we talk about the auxiliary equation. I think in the exercises, nakasama tong proof ng Theorem 4.2.1, tas may hint sa paggamit ng Euler's formula. Okay, so you can try that out on your own. But essentially here, sinasabi ng Theorem 4.2.1, actually 4.2.1 ba dapat to? I think it should be 0.2 already, yeah. Anyway, doesn't matter. It's not, the numbering is not a big deal, right? So on the Laplace transform ng sine kt ay k over s squared plus k squared. The only assumption here is that s is greater than 0. Okay? So k, that's whatever the phase multiplier here inside the sine function over s squared plus k squared. So that means Laplace transform ng sine 2t, the 2 will go up kasi siya yung value ni k over s squared plus 4. Laplace transform ng sine 3t, kunwari wala, kita pa rin pala. Laplace transform ng sine 3t ay 3 over s squared plus 3 squared. So that's how I got the 9. And lastly, Laplace transform ng sine 4t ay 4 over s squared plus 16. Good? Ang bilis lang palang i-discuss nito, no? Pero ano to, kasi madadali yung mga functions pa na involved, ano? Hindi ko alam kung ano yung limit, ano yung mga lahat ng elementary functions na kasama dito sa slides. I actually forgot. But I also provided you with a cheat sheet ng Laplace transform. Parang table na siya ng mga Laplace transforms at sa mga important properties niya. Okay? So this would be our second formula insofar as this section is concerned. So Laplace transform ng sine kt ay k over s squared plus k squared. Right. Moving on, Laplace transform ng cosine kt. Ang Laplace transform ng cosine kt ay s over s squared plus k squared, assess provided s is greater than 0. So question is, how is this different from the formula for the Laplace transform of sine kt? Ano pinagkaiba nila? Do you remember the difference or do you notice the difference? Kasi para magkamukha sila. Ano yung pinagkaiba nilang dalawa? Hindi niyo napansin yung pinagkaiba? Maybe I should flash sine kt back. So sine kt is k over s squared plus k squared. The Laplace transform ng cosine kt ay s over s squared plus k squared. Oh, thank you, Jan Rensis and Crystal. Yes, the numerator. So sine, ang numerator niya ay yung phase nung sine. Ang numerator ng sine ay k. Pero ang numerator ng Laplace transform ng cosine ay yung variable s. Yung frequency variable na s. Okay? So it's s over s squared plus k squared. So it's easier to remember kasi yung cosine laging s yung numerator niya. Except kung meron kang constant multiplier na nasa unahan ni cosine. Alright? And then the denominator is still s squared plus k squared. So I guess these three illustrations are straightforward. They are self-explanatory. Direct application of theorem 4.2.3, just keeping in mind what the value of k is and plugging in k squared as the second term in the denominator. Okay? So dagdag natin sa listahan yan. Formula ng Laplace transform ng cosine kt ay s over s squared plus k squared. And you notice what we get is purely a function of the variable s. Kasi nga lumipat na tayo ng domain. Ang domain natin kanina ay t, cosine kt, yung pinag-workan natin. Pero sa Laplace domain, ang variable lang natin ay si s. Okay? So essentially, para siyang parallel universe, para tong multiverse. Kasi hindi lang Laplace transform ang meron. Meron pang Fourier transform, meron pang radon transform. Maraming klase ng transform na ginagamit sa mga ODEs. So para silang multiverse. So sa totoong mundo, sa time domain, cosine 2t yung function. Pero pag pumunta ka sa kabilang universe, sa parallel universe, ang itsura niya ay s over s squared plus 4. Yun yung kanyang representation dun sa kabilang mundo. Kasi sa mundo natin, sa t domain, nag-exist yung mga derivatives. Sa Laplace domain, yung pagdi-differentiate kakaiba. Mas madali dun sa parallel universe na yon yung pagdi-differentiate. May kita nyo mamaya kung ano yung nangyari sa differentiation doon. Pero essentially, mas simple kasi dun sa kabilang mundo yung differentiation. Kaya gusto natin sana yung ODE sa ating mundo ay isosolve natin dun sa mundo ni Laplace. Kasi sa mundo ni Laplace, ang simple ng derivatives. Alright? Tapos saka na lahat ng i-convert. Kung ano yung solution sa Laplace domain, i-convert ko lang siya pabalik dun sa time domain. Okay? Alright. Eto pa. Laplace transform ng t to the n. Ang Laplace transform ng t to the n ay n factorial over s to the power n plus 1. So n factorial over s to the power n plus 1. Again, if you want to prove this theorem, all you need to do is to solve for the improper integral from 0 to infinity of e to the negative st times t to the n dt. Well, looking at this form, I believe mag-integration by parts ka lang dito. All right, n times, all right? So halimbawa si n ay equal kay 1. Ito na naman, ang dami kong adlib. Sabi ko na, kaya hindi ako natatapos eh. Pag gusto mong evaluate yung Laplace transform na to ng, ni t, right? Kunin mo lang yung IDP na to. So u dv, pipiliin kong u ay si t, derivative niya ay 1, tapos mag-0 na siya, tapos si dv ay e to the negative st, mag-i-integrate ako ngayon. Ito ay magiging e to the negative st over s. Tapos ito ay e to the negative st all over s squared. Kaya may negative sign pa pala, no? So magkakaroon to ng negative. Ito ay magiging positive. Tapos, hindi ko na kailangan mag-integrate kasi IBP ako. Diagonal signs, opposite sign, alternating signs. So the improper, the definite integral is this guy plus this guy. Tapos kukunin ko yung value niya from 0 to b, take the limit as b approaches infinity, you will see that you will have e to the negative STs in the numerator for the antiderivative. So that means gusto mo dyan, yung t mo, yung, yung s ay gusto mo maging positive para maging exponent ay para yung exponent ay maging negative infinity sort of. So e to the negative infinities, everything will go back to zero. So magko-converge yung improper integral. So essentially, that's how the formula revolves. And now you see why kung bakit nagkakaroon ng s squared dun sa denominator. Kasi kung t to the 1 yan, so ibig sabihin ang Laplace transform niya ay 1 factorial over s to the 1 plus 1. Doon kasi sa integration by parts, meron kang s squared. Or doon manggagaling yung s squared. Okay? So yeah, add that to your list. If you want to write the proof, well, you need to be extra patient in solving for the improper integral. And again, this bunch would be direct applications of the theorem. Let's see. Yeah. So for instance, Laplace transform of t cubes. So that's going to be just 3 factorial over s to the 3 plus 1. So that's going to be 6 over s to the 4th, provided that s is greater than 0. Okay? Sana ganito lang lahat kadali, ano? Kaya lang ang daming formula na involved. Nung undergrad ako, ito yung pinaka-ayoko. Kasi mahina ang memorya ko. So, parang mas okay pa sa akin na nag-evaluate nung improper integral every time. But of course, that's impractical. So at least sa exam, sana matandaan nyo itong mga Laplace transforms. Ano? Okay? Do you guys can see any complication with this topic? Because I can see any big problem. It looks straightforward to me, hopefully to you too. Or may problema ba? May napo-foresee ba kayo na pwede kong pahirapin itong napakasimpleng problem na to sa exam? Para ma-discuss natin siya today. Wala naman, no? Ang pinakamalaking complication lang, halimbawa, ipa-compute ko ang Laplace transform ni e to the negative 3t plus sine ng pi t minus cosine ng pi over 2t plus t to the 100. But lagyan natin ng constant multiplier. So you'll just apply the linearity and do the Laplace transformation term by term, ano? So I guess that's pretty straightforward. So unless you have questions. Madali to kasi ano pa lang to, introduction pa lang talaga, ano? Okay. Now for other interesting functions, the Laplace transform of the function f doesn't require f to be continuous. Posibleng discontinuous yung function capital F and yet meron pa rin siyang Laplace transform. Because anyway, the Laplace transform again is just an integral. Tapos alam na natin lalo na yung mga nag-math 155 dyan. Ang integral ay nag-exist provided yung point of discontinuity ng integrand ay finite. So ibig sabihin kahit discontinuous yung inyong function, posible pa ring mag-exist yung Laplace transform. The only requirement really is the convergence of the resulting improper integral. Because kung meron siyang point of discontinuity within the interval 0 to infinity, pwede mo kasing hatiin yung interval na yon into parts wherein your function capital F will be continuous on each piece, tapos integrate them one by one. Then only one of those integral pieces will be an improper integral. And the existence of the Laplace transform will be dependent on the existence of that improper integral, which is a piece in the bigger puzzle. Okay? So halimbawa, meron tayong function h. Ito yung itsura niya. Siya ay equal kay 5 when t is greater than 4, pero siya ay equal kay t when t is between 0 and 4. Well, if you look at the graph of this function, so from 0 to 4, siya daw ay equal kay t. So kapag ka si t ay 0, si y ay 0, so I'll put the hole there. And when t is equal to 4, y supposedly equal to 4. So ito yung itsura ng graph on the open interval 0 to 4. So ito ay 4. Pero when t is greater than 4, ang value na ng function ay 5. So this is how the function h looks like, right? So it's clearly a discontinuous function, but that discontinuity will not prevent us from computing the Laplace transform. We just need to be careful in evaluating the improper integral and be mindful of the properties of the definite integral. So for instance here, computing ko yung Laplace transform niya. By definition, ang Laplace transform ng function h ay integral lamang from 0 to infinity ng e to the negative st times the function h. Tapos ngayon, dahil magkaiba yung itsura ni h on the interval 0 to 4 and on the interval 4 to positive infinity, I will split up my integral of integration into two parts. The integral from 0 to 4 and the integral from 4 to infinity. And on each of these intervals, yung ating function h will be continuous, right? So h is continuous on the open interval 0 to 4. So we can use the fundamental theorem of calculus to evaluate this guy. This will not be an improper integral kasi ang h of t natin kapag kasi t ay between 0 and 4 ay t lamang. So this is continuous. So ibig sabihin this integral will exist kasi hindi siya improper integral. So by one of the theorem of Riemann, dapat ito ay mag-exist itong definite integral. Gagamit lang tayo ng fundamental theorem of calculus. On the other hand, meron kang matitira integral from 4 to positive infinity, pero from 4 to positive infinity, si h ay constant function 5 lamang, so h will be replaced by 5 over this interval, and then we'll perform this integration. And then this 5 goes out because it's just a constant. So ito lang yung i-integrate natin. So we know right off the bat, this will exist. Kasi nga by the Riemann integrability criterion, continuous kasi yung integrand sa interval 0 to 4. So ibig sabihin, laging mag-exist yan. So yung existence ng Laplace transform ni h basically hinges on the existence of the Laplace transform of this guy. Now, you can compute this improper integral if you want, pero pwede akong gumamit ng isang shortcut o isang trick para sa pag-evaluate nitong integral na to. I can look at it as 5 times Wag na lang pala kasi mag-change of variable ako, mas maguguluhan yung discussion Kasi kamukha kasi to, look at this. This integrand kamukha siya ng Laplace transform ng 1. Pero ang problema lang yung bound of integration dito ay 1 to 4. So, pwede ko naman itong i-split into two integrals pa, pero ayoko nang guluhin yung buhay nyo. Pero there's a shortcut here which is a play on the integral, right? Pero natatempt pa rin akong ibigay yung shortcut. So pwede nyo kasi itong isulat as integral from 0 to infinity ng e to the negative st dt minus integral from 0 to 4 ng e to the negative st dt. Tapos itong unang integral, ito yung Laplace transform ng 1. Okay? Which can be seen as the Laplace transform ng t to the 0, which is 0 factorial over s to the 1. So it's going to be 1 over s minus whatever this integral is. This integral is easy to evaluate. Tapos may times 5 sa labas. Yun yung shortcut sa pagka-calculate. Pero you can just evaluate this as an improper integral, and that will be perfectly fine. Pero dito, iniwasan ko kasi yung pagiging improper integral niya. So those are some of the tricks that you pick up along the way. Habang tumatanda ka, marami kang na-discover na shortcut or naiisip na paraan para hindi mo gawin yung mga ayaw mong gawin. Tulad yan, ayoko mag-improper integral. So hinanapan ko talaga ng paraan paano siya ma-compute. Paano ma-compute itong part na to without improper integrals. But if you are more straightforward in thinking, then you can just do first integration by parts dun sa unang term. Pero alam ko naman mag-exist yan. So just follow the solution here. Eventually, you'll get what? You'll get this after you do the improper integral. So, pero ito pa lang yung first term, yung sa integral from 0 to 4. We still need to add to this guy the improper integral. Ito yung inano ko kanina, yung kinoconsider ko kanina. Evaluating it as an improper integral, if you're patient enough, so papalitan mo yung upper bound by a dummy variable, but take the limit of the dummy variable as it approaches positive infinity. Do the find the antiderivative of e to the negative st. Evaluate it from 4 to b. You're gonna get this guy, and then get the limit as b approaches infinity. But that limit will only exist when s is greater than 0 kasi may nakaakibat siyang minus sign. If s is actually mag-exist ba yung integral? Yeah, I think it's necessary here that s is greater than 0, because if s is negative, this will blow up to negative infinity, and that will be a big problem, you know? So yeah, but essentially, if those conditions are met, this improper integral simplifies to 1 over s e to the 4s. Okay, and so in all, the Laplace transform of e to the ht, which is a discontinuous function, is basically the first integral, the one from the integration by parts, plus the improper integral coming off this piece, and this would be the total. Ito yung Laplace transform ng discontinuous function h. All right? So kailangan ba ng konting moment to digest those parts of the solution? Okay, hold on. Mag-check lang ako ng email. Okay, all good? Yun nga lang, bago tayo makarating dun sa kabilang dimension ng Laplace transform, nag-i-improper integral tayo, ano? But once you have the theorems, or if you have the table with you, madali na yan. Kasi mga elementary functions lang naman usually yung kinukunan natin ng Laplace transform. Right? Let's see. Oh, tapos na yung section 4.1 and 4.2. So essentially, ito yung sinasabi ko kanina, na madaling paraan or an alternative proof to derive the formula for the Laplace transform of the sine and cosine functions. Gagamitin yung tinatawag natin na Euler formula sa complex numbers. Yung e to the it ay pwedeng masulat na cosine of kt plus I sine kt. We use this when we talk about the complex roots of the auxiliary equation for a general linear differential equation with constant coefficients, right? And from Euler's formula, totoo tong identity na to. Ang cosine kt ay equals sa e to the ikt plus e to the negative ikt all over 2. And then you can use this to show that the Laplace transform of cosine kt ay equals sa s over s squared plus k squared. So this is an alternative to the integration by parts that I mentioned earlier. Dito natin nakikita that there are multiple ways to kill a cat. Pardon the pun or pardon the idiom para sa mga cat lovers dyan. Pero maraming paraan para sagutan ang isang problem sa math. Ano? So essentially here, all you need to do is to get the improper integral from 0 to infinity of e to the negative st. Then instead of straight away cosine kt na mangangailangan ng integration by parts, pwede nyo ilagay dito ay e to the ikt plus e to the negative ikt all over 2 dt. Tapos paghiwalay nyo to sa dalawang integral, tapos makita nyo on each piece, magkakaroon ka lang ng isang exponential. e to the negative st plus ikt all over 2 plus integral from 0 to infinity ng e to the negative st minus ikt all over 2. Tapos, sa integration, para dun sa mga hindi pa nag-165, yung rules sa integration nag-a-apply kapag ka meron ka ring I. I-treat nyo lang si I to be a constant, as if it's a real number. So same rules for integration applies. Okay. So think about how to answer exercise 1. Inisip ko sana na ipa-homework siya sa inyo, pero siguro marami kayong ginagawa ngayon, so I'll skip the homework muna. So wala muna tayong new homework for today. Okay? So, but this is something to think about. Malay nyo, ito yung ibigay ko sa theoretical part nung pre-final exam. Prove it either way, using integration by parts or using Euler's formula. So try this whenever you have the time. And if you can do it for the cosine, then you can also do it for the sine function. Okay. And then play with the exercises number 3. Or pwede naman nating sagutan ngayon yung exercise 3. Para mas ma-practice tayo, ano? Gusto niyo ba mag-recitation? Sige nga, I need volunteers para sa ABCD. Type in the chat. Madali bang i-type yung solution or hindi? Baka pala mahirap i-state yung solution. Or bigay ko na lang muna yung answer and then you check your solutions. So let's see. Let's solve this together. Let's try letter A first. Laplace transform ng e to the negative 2t plus 4 e to the negative 3t. I'll use the linearity of the Laplace transformation. So I can do term by term transformation. Una, ita-transform ko muna yung e to the negative 2t. Ang Laplace transform ng e to the negative 2t ay 1 over s plus 2. Right? Ang k kasi dito ay, ang k dito ay negative 2. Ang formula ay 1 over s minus k. So I'll have 1 over s minus 2. So it's going to be s plus 2. Pero take note here that the condition is that s should be greater than 2. All right? And then plus Laplace transform ng 4 e to the negative 3t. I can just copy the constant 4 out of the Laplace transform times 1 over Laplace transform times the Laplace transform of e to the negative 3t. That's going to be 1 over s plus 3. The condition here is that s is greater than negative 3. Yung kanina pala, s should be greater than negative 2. Okay? So that's the answer for number 1, right? So this is the Laplace transform. But what's the condition? Now, for this, to find the condition or the domain, kailangan kunin yung intersection ng mga conditions. Okay? So here, the condition is that s is greater than negative 2. So kung sa number line yan, si negative 2 ay nandito. So, andito tayo dapat para mag-exist yung unang term. Then yung pangalawang term ay mag-exist kapag greater ka kay negative 3. So ito naman yung kay second term. Then we'll need to take the intersection. So that means dito parehas sila nag-exist. So therefore, the condition here is that s must be greater than negative 2. Okay? Is that all right? Does that make sense? Okay, good. Then similar yung sa letter B. Let's try yung letter C. Bakit hindi niya sinama yung mga cosine? Nahiya pang pagsama-samahin lahat ng mga functions involved. Pero sa letter C, Laplace transform ng t squared, that's 2 factorial over s cubed. Condition here, s is greater than 0. Then plus, linearity ng Laplace transform, copy the 4. And then Laplace transform ng t. Laplace transform ng t ay 1 factorial over, tama nga ba? Yeah, n factorial over s to the n plus 1. So this is going to be s squared. Tapos minus 5, you can think of it either as e to the 0t, Laplace transform ng e to the 0t, or pwede mo siyang tingnan yung 1 to be the Laplace transform of t to the 0. Gawin ko na lang t to the 0, so that's going to be 0 factorial over s. Pero kung in-interpret mo yung 1 to be e to the 0t, you're going to get 1 over s minus 0, which is the same thing as what we obtained here, right? So apparently all the conditions here are s greater than 0. So therefore, ang Laplace transform nito ay 2 over s cubed plus 4 over s squared minus 5 over s. Okay? And a similar condition, s is greater than 0. And a similar solution can be done for part D. $11:01 pa lang pero pagod na ako. Hindi talaga ako sanay ng mabilis magturo. Okay, everything making sense? Ito yung problema, hindi ko nakikita ang mga itsura nyo. Kasi ako hirap na hirap ako. Feeling ko ang bilis. Pero, yeah, at least nagta-thumbs up kayo ngayon. So, alam ko na gets nyo, no? Kasi ako sanay talaga ng mabilis magturo. Okay. Kaya pala. Kasi nasa next page pa yung mga challenging questions, right? Now, what are the hard parts of this? Let's say. The big problem here would be how to deal with parts F and G. All right? Kasi si part CE, straightforward application lamang ng definition or ng theorem natin with the Laplace transforms of sines and cosines. What would be difficult would be F, G, and H because they all involve a fancy function of cosine and sine. Hindi lang sines and cosines pero naka-square pa sila. So, para dito, kailangan nyo gumamit ng trigonometric identity. Unahan ko na kasi madali yung H. Isipin nyo na yung F and G kung ano nga ba yung trig identity para sa kanila. Pero sure ako sa letter H, Laplace transform lang. Saan equal yung H? Sige nga. Para at mabilis, saan equal yung letter H? Uy, ba't ang tagal? Letter H, saan equal ng letter H? Uy guys, hindi ba obvious yung letter H? It's the Laplace transform of cosine squared 3t plus sine squared 3t. Will you be surprised if I say the answer is not 1? The Laplace transform na yung tinatanong ko. So dapat ito ay 1 over s. S greater than 0. Alright? Kasi ito ay cosine squared plus sine squared. Remember, cosine squared an angle plus sine squared of another angle will be equal to 1. So this is just the Laplace transform of 1. Ang Laplace transform ng 1 ay 1 over s when s is greater than 0. Okay? So trig identities. How about letter F? So dito medyo masinsinang trig identity yung kailangan natin. So for this guy, kailangan natin yung trig identity na ito ay equal sa 2 Laplace transform. Nilabas ko na muna yung 2. Ang cosine squared ng theta, according sa Wikipedia, kaya nag-altab muna ako kasi kakaibang trig identity yung cosine squared. Ano? So ito ay equal kay, medyo madaya ako, meron akong kodigo rito. So cosine squared ay 1 plus cosine 60 all over 2. Okay, galing siya sa identity na ang cosine squared theta ay equal sa 1 plus cosine 2 theta all over 2. Ito yung identity na ginagamit nyo sa pag-i-integrate ng even powers ng sines and cosines. So cosine squared 3t, so dun sa nakabox na formula, yung theta, palitan nyo lang ng 3t. So that means cosine squared 3t is equal to 1 plus cosine of 60 all over 2. Essentially, this will be, or the 2 in the denominator can come out, canceling the 2 in front. So it's going to be the Laplace transform lamang ng 1, which we know to be 1 over s, and plus Laplace transform ng cosine 60, ano Laplace transform ng cosine 60 is going to be s over s squared plus 36. And the condition is that s must be greater than 0. So that's the Laplace transform. And a similar identity can be used for sine squared. Yun nga lang, sabi ni Wikipedia, ang sine squared theta ay equals 1 minus cosine 2 theta all over 2. So yun naman yung gagamitin nyo for letter G. Ito pala yung challenging, ano? Pag hinaluan mo na ng trigonometric identity yung sines and cosines. Okay. And then just to add to our list of Laplace transforms, we do have number 4 and number 5. Try to show this using, actually straightforward din yung proof nito. Ito ay Laplace transform ng hyperbolic cosine at hyperbolic sine. Sila ay kamukhang-kamukha ng Laplace transform ng sine and cosine. Remember, Laplace transform ng cosine ay s over s squared plus k squared, provided that s is greater than 0. Okay? So in this particular case, nagbago lamang yung sign ng nasa denominator. S din yung numerator. Saka nabago lang ng konti yung condition. Ang condition ay s is greater than k. But the idea, hindi masyadong crucial itong mga conditions sa Laplace transforms because what we're after is the case when s is greater than, when s is very, very large. Kaya if you choose S large enough, these Laplace transforms will all exist. Kaya yung ibang authors, hindi na nila sinasama yung condition. Kasi nga, if you choose S to be large enough, then all of the Laplace transforms will exist. Okay? Similar yung sa hyperbolic sine, ng Laplace transform ng hyperbolic sine. Kamukha siya nung sa sine, na k over s squared plus k squared. It's just that the plus here was replaced by a minus kapag hyperbolic na siya. The condition also changed. Well, how will you write the proof here? You're going to use the definition of hyperbolic cosines and hyperbolic sines. So remember that hyperbolic cosine of x is just e to the x plus e to the minus x all over 2. So ito yung ilalagay nyo dun sa integral from 0 to positive infinity. And if you evaluate that improper integral against e to the negative st, you will get this guy. Okay? So you can just search the net for the proof that the Laplace transform of cosh of kt is s over s squared minus k squared. And then you can just read the proof and then follow it up. Medyo computational naman siya, so madali siyang intindihan. Okay? And then there's a bunch of other exercises here. Ito naman yung practice nyo para sa pag-i-integrate piece by piece. All right? So katulad ng ginawa natin kanina, hinati natin yung integration interval. Instead of straightforward from 0 to infinity, we divided it into several pieces so that we know how f exactly looks like on each of the pieces. So I think you can also follow exercise 6, but let me know if you foresee any problem with it. And ayoko na magsimula. Pagod na ako. So we can, I think. All right, so you can spend the next 10 minutes allotted for our class para mag-practice, okay? Hindi naman required na i-submit as homeworks. But you can try some of the interesting problems in the exercise set for sections 4.1 and 4.2. But I don't want to overload you with information at saka pagod na rin yung aking lalamunan, ano? So gusto ko na muna magpahinga. So bonus na muna yung 10 minutes. Akala nyo na-afford pa nating magpahinga, delayed na nga tayo. But anyway, that's fine. Okay, so I will stop here. And then on Wednesday, we'll talk about section 4.3. Medyo holiday ng December 8, no? Tapos Tuesday yon. Yung dalawa yatang section ay TTH sila. So sila naman yung mawawala ng pasok. So kaya pwede tayo mag-relax ng konti. Pero delayed pa rin tayo ng 2 meetings sa kanila, no? Pero anyway, either sasabayan nila yung coverage natin ng exam or mag-iiba tayo ng exam, ano? So kakausapin ko pa yung 2 lecturers. Any questions? Oh, by the way, starting next week, I will start handing out the project kasi may final project tayo na worth 20% nga ba? So the final project will be due on the last day of the final exam, which is January 11. So you have lots of time to answer it. Ang gagawin ko na lang ay bibigyan ko kayo ng practice problems or application problems kung saan bibigay ko yung step-by-step step-by-step instructions na i-carry out nyo para ma-solve yung isang word problem. So hindi ko na kayo pag-iisipin ng sarili nyong problem. So bibigyan ko na lamang kayo. Okay, sure, Crystal, just to hang out after we close the session so you can ask her question. So okay lang ba yon? So ganun na lang yung project pa kasi yung iba dyan nagwa-191, nagwa-174. So sila yung nag-iisip ng sarili nilang problem. So what I'll do is to assign you with some problems na pwede nyo sagutan. Application problems sila pero i-specify ko kung step by step kung ano yung kailangan nyo gawin. But for that, I need to group you into several groups. Ano? Okay lang ba na by group? Siguro group of around 3 members. Anong gusto nyo? Kayo na yung mag-group o for a change ako naman yung mag-group? Ako na lang yung mag-group kasi walang nagsasalita. So ako na lang yung mag-group tapos 3 members, around 3 members per group. And then I'll give you the exact instructions next week. Alright? Para masimulan nyo rin. Saka para mahati yung trabaho nyo kasi probably dahil ang dami nyo nang gagawin until the last day of classes, you might be constrained to do it over the Christmas break or during the first week of the finals. So kaya mag-division na playboard kayo, no? So I think that's it. Thank you guys for joining today, and let's see each other again on Wednesday. You have a good weekend, everybody.